All righty, we're ready to rock and roll. So a couple little things to note. As you know, the deadline was pushed back a week. My thought for you guys as students would be try to still adhere to the January 8th deadline and use that last week for any tests that, you know, might spill over. But it is nice, a little bit of breathing room, okay, that we've got that extra week, and use it if you need it. Another question that came up with my 30-1s, but it would also relate to you guys. The question was, do you have to ask for an exemption on the diploma? Like, do you guys all have to fill in a form? And I don't know the answer to that question. I would assume, so this is my assumption, but I need to...
I got an email about that from my teacher, the resource teacher, support teacher.
Okay.
But the one I go and do the tests, I got an email from her saying if you want to exempt from it, you can just email her back. I haven't emailed her back saying I don't want to do the diploma yet. So yeah.
Okay. And I'm thinking that
I think your resource teacher.
Right. And you guys are all from all over the place, right? All the different schools. And so there might be a way where I could collect the information and get it to your schools. So we'll find that out. I kind of assume if you didn't show up, you're going to get an exemption. But anyway, that might not be a true thing to assume. So I'll do some research. I've got it written down to ask my VP that's away for a little bit, see what she says we should do to deal with that. We've got lots of time. And the other question that was asked, I don't know if it's this big issue for 30-2 students, was the fact that some of my students were worried that the post-secondary institution they were going to would look more favorably on their entrance if they did the diploma, especially if they were going into a really, like something that was really hard to get into. And so I don't know if that's the case or not. I just said to the students, ask your post-secondary institution what they think. The other thing to think about, and this might relate to a few of you, is some students are really good test takers. Really good test takers. So if you are a really good test taker and you can look back through your marks in, say, just this class and see that your test marks are normally higher than your assignment marks, you might want to give it a kick. But it is a risk because it's not like you can take it a kick at it. And if you do badly, not count it, it counts. So I'm assuming not many people will actually try it, but those are some of the things to think about. The other thing that I wanted to talk about was the Module 8 project. So the Module 8 project is optional. If you get to the end of Module 7, do the Module 7 test, and you go, peace out, I'm done, cool, right? And the moment you're done the Module 7 test, you are truly finished the course, because there is no, as far as I know, I'm not giving a final exam unless someone decrees that and I'll have a heart attack, which could happen. At this point, there's no final exam that I have ready. But the Module 8 project, if you choose to do it, I will try to replace something that didn't go so well for you. Okay, so we're going to look at, I have to look at this individually, depending on what you do on the project and how well you do it. I will say most people that do the project do a nice job. So it is optional. If you run out of time, great, you're not going to get penalized. If you don't run out of time and want to spend some time on it, awesome. You can ask me for some thoughts. We can have a phone conversation about what you might want to do. I can share some things that students have done in the past that have been super helpful and super well received and done well. And then you can decide at that point. So that would be the conversation about the Module 8 project. Okay. Okay, so I am going to do some Module 6 review, if that's okay with everyone. If you have, and I know some of us haven't got there, so I'll be cognizant of that and careful of that for those that maybe aren't on Module 6, that we're going to kind of, okay, so we're going to kind of look at that. So I do this in my 3-1s as well. I know some are at the end of module 6, some haven't viewed it yet. So I try to be aware that I need to give you some backgrounds. I don't just throw you in the fire and let you sizzle away, right? So I will go back and just get a little oriented, because I was pre-planning these sections and sessions, and it's like, well, great, I pre-plan it, but no one's where I am. So that's kind of useless. So I do just wait until you guys are here, till I can have a conversation about who came, because that's it's lovely. I have a recording, hopefully, but it's nicer to be able to talk with students that are actually face to face with me. Okay, so have a little thought here as to where we're going to start. This is sinusoidal functions, and we can do a number of things with this. Sinusoidal. And it's kind of, they're not really sine functions. We do sine graphs. It's sine and cos graphs is what it is, really, in a nutshell. There's some other things that we do, but generally that's what we're talking about. And also you are introduced to a new way of measuring angles called radians. So I'm going to start with that discussion of radians and show you how radians and degrees relate. That's what we're going to look at here. We're going to go back to the idea of a circle. Okay, so I'm going to draw a circle as best I can. Okay, and we're going to look at a circle with a radius of 1 for our conversation. Now, from back in grade 9, 10, something like that, you knew that the circumference formula was 2 pi r. Right? That might ring some bells. You don't have to memorize that, but that's something that hopefully rings some bells in terms of circumference. And that measures the entire distance around the outside of the circle from start all the way through. Okay. The other idea that you probably already know is if we were to start here and rotate all the way around the circle, we would also go through 360 degrees if we want to look at it in a different way, right? Then if we say, well, one way to measure around the circumference of the circle is 2 pi r, and one way to measure around the circumference is 360 degrees, there must be something going on here that equates them. And so we can write that 2 pi r is equal to 360 degrees. Now we're looking at a unit circle, like a base circle. So we put the 1 in there and we get 2 pi equals 360. Or if we divide by 2, we get the relationship that pi radians is equal to 180 degrees. Okay. And I think we talked about that last time, if memory serves me right. I think that we did this, and we talked about how to convert from radians to degrees. Am I right with that? Did we work on this last week in tutorial? No, we didn't. Okay. All right. So because the problem is I do 3 classes and they're pretty much the same content. So we'll carry on with this. So there are 2 ways of doing measuring of radians and degrees. What would be really good for you guys to know though too is generally, so this little piece is really important. If you don't remember how I got there, no worries. If you're writing a formula sheet out and you just put pi radians as 180 degrees, that's important. But also for the 30-2s, because we do sort of a lot of approximating, it might be interesting or good for you to know that if you think of pi being approximately 3, so 3 radians is 180 degrees, you can use this as an approximation. 1 radian is approximately 60 degrees. I don't use that very often, I'll be honest, because I teach much more of the -1 stream, and I find it just as easy to show you -2s the same way as the -1s, but just kind of keep that in mind, that it might help you to convert and check your work a little bit. So then we're asked when we get started in this module to do some conversions between radians and degrees. So let me show you what I think is kind of a foolproof way of doing this. So let's do some conversions. So let's say the first one is that we want to convert 120 degrees to radians. And we want to leave the pi in the answer. Just so you know, okay? I set up a ratio because in my math background, I find if I can use ratio, the math is just so easy with cross multiplication. So I write down the known piece of information that pi is equal to 180 degrees. I leave the RAD out because it's units. So pi equals 180 degrees. And then underneath it, I write down what I'm given, which is the 120. And then this is my unknown. I put an X there. So we get a little ratio. Pi over X equals 180 over 120. And then I cross multiply. This times this equals this times this. So you get 180 multiplied by X equals 120 multiplied by pi. That's just a straight cross multiplication. And I divide by 180 on both sides. That cancels this. And I get this answer. Now, hopefully you guys are getting good at your calculators because your calculator will reduce the 120 divided by 180. Now you can do it longhand, but we want to leave the pi in the answer. So in our calculator, we want to put 120 divided by 180 and then have the calculator change it to a fraction in lowest terms. So you go 180 divided by 120 divided by 180, enter, and then math, enter, enter, right? Math, enter, enter always changes it back to you for you. So do that, 120 divided by 180, enter, math, enter, enter. You should get that answer. X equals 2 pi over 3 or 2/3 pi or however you want to write it. Okay. So why don't you guys try one? We'll do a conversion of degrees again. So convert for me 330 degrees to radians. And again, we want to leave the pi in. Follow the guide there. And I'll just pause this for a minute. Okay, so the process for this, exactly the same. We start with pi and 180 degrees. And then on the bottom, we put X, but this time we have 330 degrees. And we cross multiply. So we get 180 times X equals 330 times pi. Divide by 180. So we get 330 pi over 180. Calculator time. Okay, so we go 330 divided by 180, math, enter, enter, and we should get 11 pi over 6. Okay, so that's with the pi in. Now, if the question says that they want it to a decimal place, oh, the math, enter, enter thing. Oh, let me talk about that. Okay, so does everyone have this calculator? Or you don't have your audio or your video on, so just give me the thumbs up if you have it. Oh. You don't. Okay, well, then I don't know what to suggest. If you don't have this calculator or a calculator like this, you have to do the simplification on your own. Okay, so then it's up to you to do the reducing. And so what we would do here, I mean, I can show you the math, but it adds a complicated layer to this, is that you figure out what will reduce into here and into here to make it to lowest terms. So you could divide this by 30, and that gives you the 6. And this divides by 30 and gives you the 6. Okay, so it is pretty critical. It is a piece of technology that you should have for this course, for sure. Something like this, okay? Now, something else, excuse me, that comes up is that sometimes it'll ask you to write the answer as a decimal. So let's just do, let's continue here on number 2. Let's say it says you want it as a decimal. Well, that's super easy. All you do is go 11 and then use your pi button, the 3.14 ... You just actually just evaluate on your calculator, okay? So you go 11 times pi divided by 6, and you get a decimal of 5 point, I didn't say where to round it off to, 5.76. Something like that. Okay. Now, converting the other way. So if we're asked to convert the other way, say we want to do pi over 2 radians to degrees. Let's say that's the question. Okay. You set things up exactly the same way. It's beautiful this way. So you get pi equals 180 over pi over 2 equals x. The x is on the other side, but the setup is exactly the same.
So if you when you're doing, if you times 330 times pi and divide it by 180, you should get the same answer as you did with 11.
Correct. It's just, you got to be careful. If the direction is that you want to leave the pi in, then once you get to it's kind of messy here now. Once you get to this stage, you have to reduce the fraction to 11 over 6. If it says to get a decimal, then you just grab your calculator out and plow it through your calculator. So you just have to watch how the answer is wanting to be done. So now when we look at doing this question, we cross multiply again, we get pi times x equals 180 times by pi over 2. Now notice you got pi on both sides. Remember equation solving, what you do to one side, you do to the other? Cool. Get rid of the pi's. And then this becomes x equals 180 multiplied by 1 over 2. And then you get 90 degrees if you try that in your calculator. So this procedure will work for any conversion. You just use the top as your pi and 180, and then you put the radians or the degrees underneath and cross multiply. It's quite lovely. Let's do one more of these where say that the angle is given to us without the pi in it. Let's say I want 3.61. No, that's a bad number. Sorry, let me give you something else. 2.34 radians to degrees. Now notice there's no pi there. That's okay. We're going to be able to deal with it. Start exactly the same way. Pi equals 180 degrees. 2.34 equals x, like that. Same process as we've been doing. We get pi times x equals 180 multiplied by 2.34. Now there's no pi on both sides to cancel because there's no pi in the other one. That's okay, just divide by pi. Now grab your calculator out. Go 180 times by 2.34 divided by pi. And then get your answer. So 180 times 2.34 divided by pi. Should get 134 degrees. If anyone can't get that, let me know. You can just go in the chat bubble and let me know that you can't quite get that one to work for you. Okay, any questions on that one? We all good? Okay, so now the next section, we absolutely have to have a graphing calculator. This whole module revolves around the graphing calculator. I just apologize for that, but that is the curriculum that we're asked to look at. So you need to grab your graphing calculator out now. I'm going to get rid of this because I want to be beside my piece of graph paper. And we're going to get our calculators out and practice doing some graphing. Now, when we're asked to graph, we can be asked to graph in radians, and we can be asked to graph in degrees. Because you probably have more exposure to degrees. We're going to start with that, and then we'll move to radians. Okay. We want to graph on our graphing calculator y equals sine x and get a vision of what it looks like. So before we can do that, there are a number of things we have to do. Step number one, we need to make sure the mode is in degrees. Okay, so on the graphing calculator, there's this button that says mode right here. Okay, you got to hit it, and you got to go down to the third one and see that degrees is darkened, which mine happens to be. So the last time I was in this calculator, I was in degree mode. Make sure that is darkened. That's step number one. Step number two is you need to change your window settings. And good window settings for X are -360, +360, and 90 as a scale. And I know you put them into your calculator vertically. We just write them horizontally. Don't know why, but I'm just showing you what you're going to see. And for the Y, we're going to go -2 to 1. So go into your window settings and change those to be that. Okay. And when you've got that done, just give me the thing, the thumbs up. Good. Make sure
When do we know
those two
when
things.
to use degree and radian?
Oh, what a beautiful question. Okay. So if the question does not state whether to use degrees or radians, you have to use radians. I'm going to write that in red, and we'll get to radians in a second, but that's an excellent, excellent question. Okay. So if the question does not state unit, we have to use radians. So we'll see where we get, in our time as to what we're going to be able to accomplish, but we will do some questions in radians. Okay. Now we're ready. Step number 3. Oops, I want to change my font, my back to black. Just go into the Y equals button and put Y1 equals sine X, and then hit, so this all happens at once, then hit the graph button. Okay, so hit the Y equals button, clear anything out that's there. I had lots of stuff there from my other class. Hit graph, and you should get, you can look up at the board here. I will put it on my little piece of graph paper, but you should get something that looks like that. Cool, got that, I see it. You can show me your calculator too, that's cool. Got it, got it, got it, excellent. Okay, so I can graph it, and 1, 1, 2. And so, I don't know, it's not that easy to graph here. Anyway, something like that. I'm not going to get particular on my graph. Oops. Whew. A little wonky on the far side. Okay, so it's something called a cyclic function. It keeps on going up and down, up and down, up and down, up and down. And we can find a whole bunch of different things out about it. If we go and we want to do it in radians, oops, I better erase a little bit more stuff here. We have to change everything, right? So if we go through to do it in radians, we got to go back to the beginning, and we got to make sure the mode is in radians. We have to make sure we change our window settings. Now, these are a bit of a pain in the neck. Remember at the beginning of our our class, we had 2 pi equals 360 degrees. So when we put the window settings in, our X settings are -2 pi, +2 pi, pi over 2. They're a bit of a pain to put in. They will change them to decimals as soon as you hit enter, but Y stays the same, -2, 2, and 1. So bit of changing when we have to mess around with radians, go to radians, hit enter, then go back to your Windows settings and change them. Minus, and use the minus button, not the subtract button, or it will not work.
Sorry to interrupt, but I gotta go to work,
Okay.
so.
All right. Thanks for coming, Austin.
All right.
Hopefully
Yeah, no
this
problem.
recording will be able to be posted so you can go back and watch it.
Yeah.
Okay, we'll see you later. So actually, you don't have to change your Y settings here, just your X settings. And then you don't even have to re-put this in. This should still be in there, right? So step 3 is just to regraph it. That's the same. Works. You guys get the same graph looking at you? Okay, so be careful when you're working through questions that if you need to do it graphically and all of a sudden nothing shows up or a funky, straight line or something really weird happens, go back and look at your mode. This is the one part in the course where you have to mess around with your calculator to change modes or things just do not work. The rest of the time, doesn't really matter what mode's in, it's just a calculator and whatever. It doesn't do anything wonky, but here you have to be very, very cautious of things, okay? Now, the other thing that we need to know how to do is analyze a whole bunch of data doing sign regression. So I think I'll spend a few minutes doing sign regression as our last thing. Because it does come up and it is important for doing some of the questions on the test and on the assignment. So to do that, I don't know that I can make up data off the top of my head, but I think it's important we do one. So let me go see if I can I don't want to grab something with too much data, but we want something that will mimic what we need. So give me a moment. Okay, so here's some data. And they're asking us to determine the equation of the sinusoidal regression function for the data. All right, step number 1, anytime you're asked to do this, and there was a question asked earlier, make sure that you're in radian mode. So just double check, we should be, because we just did a radian question, but make sure you're in radian mode. Then you want step number 2, clear your lists. These calculators have a sneaky bad way of having things in the background that mess things up for us. Now, the buttons to clear your list is second function, and then the plus sign, and then option 4, which is clear all lists. I can write that a little bit bigger here. Clear all lists, and then enter. I do these steps every single time I do a graphing question that I have to put data in, every single time. I don't clear it out manually because, oh my Lord, things go bad. Okay, now we want to enter the data. So we hit stat and enter. So what your calculator should look like now is just this blank set of tables waiting, see, waiting for data. Okay, so L1, we're going to put the X values. And L2, we're going to put the Y value. So there's not too much data. Just hit enter, put it in, hit enter it here. Let me know when you guys have got it in, and then we'll do the regression part of it. Okay. Thumbs up or whatever. Let me know. I can see you guys. Perfect. Got it. All right. So we got all our data in there, and then you can just hit second function mode, right? Which will get you out of there. Second function mode to quit. Now we're going to do our regression. So the buttons you hit are stat Then you go over to calculate. So over 1, and then page down, and it is option on mine. Where is it? C, way down at C, sine regression. Now, my calculator does not ask me for anything else. I just enter a couple of times and it pops me out my answer. Do your guys' ask you for anything? Does it ask you for, okay, so put your calculator up when you get to hitting sine regression so I can help you guys out with what you need to enter, because it will look different for some people than for me. Mine just, see, pop me out a whole bunch of answers, boom. Okay, put it a little closer to your screen, Suzanne, so I can read what it says. Okay, what if you hit enter now? What does it do? Does it just sit there? Okay, so Kelsey's good. Okay, so some of you may be asked to put in information, and so then you'll want to hit the L1 button, comma, L2 button, and then close the bracket. That should allow you to get through. So what you're trying to do, and you might have to email me if this is not working, if you're watching the recording, because again, some specifics is hard to, when I'm not right beside you with a calculator. So you get this popping out, you should get this popping out, A sine bracket BX plus C bracket plus D. And then underneath, I'm gonna round these because I don't feel like writing out all the numbers, 17.11, 0.3118, I guess, if we round it off. C is minus 0.05, close enough. And D is 121.88. Okay, it's important that you can get those out. Okay, so you can't get the answers out at all? Okay, so it might ask you, oh, I don't have a calculator like yours. I'm just gonna. Okay, so something else you might have to do, so you might have to get a hold of me if you're having trouble with this in your calculator, is some calculators may be waiting for an appropriate period here as well. So now an appropriate period, and Suzanne, maybe we need to try this again, an appropriate period, you look at your X values to figure out an appropriate period. Now I did 2 pi, that might not have been a great one. So the appropriate period here could be, maybe we put 30 in there. Could try that. This is, again, when I troubleshoot calculators that are not in front of me, it can be a little tough. So if you can't get this to come out, you're going to have to just get a hold of me, and we will have to do an individual Zoom or a phone call or something. Now, if you're really struggling and things are going off the tracks with the calculator, don't forget you can always reset your calculator. So if things go really wonky and you're just not sure exactly what you have, you reset it and start fresh. You do have to go back and put all the data in and whatnot, but that is sometimes very helpful. Okay. Now, the last thing that I want to do before I wrap up in terms of the class is we're going to now assume we get this. So if you don't get it, we're just going to move to that for now. So our equation at the moment is y is equal to 17.11 sine bracket 0.3118x plus, no, it's minus, I'm sorry. It's a minus there, minus 0.05 bracket plus 121.88. Now, what if the question said, and I know that, again, I'm kind of got the test on my mind a little bit. They'll say, using this data, which is the data that's right up here, find the sine regression function and predict what the value of y is when x is, say, 12. So if they say, okay, x equals to 12, what is y? And what they want you to do is they want you to put 12 in there and then make sure you can put it in your calculator and get the right answer. So I will just make sure that we can model that we get the right answer here. So I'll write it down and then I'll get my calculator out. And we can kind of guesstimate that our answer should be, you know, between 122 and 105, because there should be some consistency in the data, but we need to actually check it out. Okay, so 17.11 sine 0.3118 times 12 minus 0.05, close the bracket, add 121.88. Okay, so when you do all of that, it might take you a minute to catch up to me. I get 112.9, so it might be given as 113 as an option. Okay, so just make sure you can power that through and get to 113. You know, even if you're not getting the equation, which is something we have to deal with. Once the equation is given, you can do the substitution in. Okay, and lastly, what would we do if this was our equation still? We're still dealing with this equation. But what if they gave us a y value and said, okay, y, so this is another question. If y is equal to 100 and what are the possible numbers we can put in here? 130, what's x equal to? That's a look at this equation. It's telling us the y value here over on this side, and we don't know the x value. You're going to have to do this graphically. So what you're going to have to do is we're going to have to go into our y1, and we're going to have to put y1 equals this 17.11 sine 0.3118 x minus 0.05 plus 121.88 as y1. And we're going to have to put y2 equals 130. And then we're going to have to find the point of intersection. So as I mentioned earlier in our class, this section is very calculator intense. So let's go put that in again, double checking. You got to be in radian mode. Now your window settings, we better mess around with window settings first. So our window settings are not appropriate for this information. Let's go back up and look at our information. This is going to predict or help us figure out what window settings for X, and this is our Y window settings. So for X, I'm going to go 0 is minimum, 30 is maximum. It looks like it goes up by a scale of 5. Those are my X window settings. My Y window settings down at mine. Okay, so it's down at 105. I don't really love being way up here. I'm going to try this and I might change it. So let's put a minimum of 100, a maximum of 150, a scale of 10. And I reserve the right to change that, okay? Because sometimes we're just going to look at this and see what happens. All right, so let's fly at it. You've got everything there, your window settings and your equations down at the bottom. It does give you a fairly decent graph. So if you use the window settings that I predicted up there, just from the data, you will get a graph that looks pretty nice. Okay, that's the trig graph part of it. And then don't forget, I kind of got to slide down here. Sorry, the screen's only so big, that we're talking about y2 being 130. So then we go back to our y equals, put 130 in y2. And you should get something like this. Now we get a variety of points of intersection. I apologize, right? So I didn't make this structure this question great. I could say find the first point of intersection, right? The first time they intersect is right there. Let's just all go make sure we can find the first point of intersection, and then we'll wrap up the recording. So the first point of intersection, remember how to do this. You're going to use the second function and the trace button and down to intersect. Okay, so I can write the buttons down rather than having my calculator up there. So to find the first point of intersection, So we go second function trace. I think it's option 5. Yep, so you just hit 5, enter. And then you just have to make sure that you're to the left. Get to the left. And then you hit enter 3 times. Let's try that. So you have to use your navigation buttons, these little dudes here. Once you get to this point, you're going to use these buttons here to get to the left. I don't know if you guys can see how it's moving backwards. Moving. Got to be to the left, so got to keep going. Okay, so as soon as you've got it on one of the curves to the left, see where it is right up here? Then you hit enter 3 times. Enter, 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 enter. Boom. It shoots out my point of intersection. I don't know again if you can read it, but I think you can once I get it up there. Okay. And I can write it down. So we get a point of intersection of x equals 1.75 and y equals 130, which is what we wanted. And so this would be our answer. Okay. So if you're working on sign regression, you might want to come back and watch this tutorial again and watch the recording, assuming that the recording works for us.